Hello everyone. In this chapters, we are going to study the system of linear first-order differential equations. First section is the linear systems. Second section is a homogeneous linear systems. Third section is a non-homogeneous linear systems. In the linear systems, we consider many dependent variables, but we consider the single independent variables. This is an example of a system of linear differential equations. We have n dependent variables, x sub 1, x sub 2, up to the x sub n. So we have n dependent variables. Single independent variable the t. So dx sub 1 over dt is expressed as a sub 1 1 times x sub 1 plus a sub 1 2 x sub 2 plus blah 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 up to the a sub 1 n times x sub n plus f sub 1. Also we could write a similar differential equations for the x sub 2s, x sub 3s up to the x sub n. For example, we could consider the two dependent variables and the one independent variables. So in this section, we only consider the case of the single independent variables, but many dependent variables. So dx over dt is expressed x plus 2y plus 1, and dy dt is 4x minus y plus 5. So we have two equations. So system of linear differential equations. So dependent variables in this case is x and y, and the independent variables is t. Okay, this is an example. Actually, we could write such equations in the matrix forms of our linear systems. So we introduce vector quantities and a matrix. So x vector is expressed x sub 1, x sub 2 up to the x sub n. So x vectors, capital X vectors has a n component from the x sub 1 to the x sub n. And A is a matrix a sub 1 1, a sub 1 2 up to the a sub 1 n. And the second row is a sub 2 1, a sub 2 2 up to the a sub 2 n. And the last row of the first column is a sub n1 up to the a sub nn. Equations is combined into the single equations. dx over dt is equal to the ax plus f. A is a matrix, x is a vector quantities, and f is also a vector quantities. The example dx dt equal x plus 2y plus 1, dy dt equal 4x minus y minus 5. So we'd like to combine this equation into the single equations by introducing the vector quantity of the x, capital X, has a two component x, y. The matrix A is defined 1, 2, 4 minus 1s. So this comes from this 1 is here, and the 2 is here, and the 4 is here, and negative 1 comes to the here. And also the f vectors is 1 minus 5s. This comes from this 1 here, minus 5 is here. So by introducing these vector and matrix forms, this equation exactly equal to the d dt x is a derivative of the vector quantity of the x equal ax plus f. So, okay, this is the matrix form of a linear system. Okay, so in this chapters, Actually, we are going to solve this system of a linear first order differential equations.